Okay. Barbara assigned me, I write, I'm a space journalist, which, depending on fake news and what your feelings are, I cover the space program for a bunch of places, space.com and Scientific American. But it's really weird, when you do it day by day, to go back and look at what happened. Because, it's a fog. After a while, there's so many things going on in the space program, not only at NASA, but internationally, in China particularly. I follow China. I am not going to do, I guess I'll be a disservice to everything that happened last year, because there's so much, you can't get it in. But I picked some highlights, and I just wanted to remember, much of it we've talked about in past meetings here. Juno and Jupiter, okay. It arrived late in 2016, but it's really doing some incredible work at Jupiter, taking some impressive new data about the big planet with a big, kind of storm ongoing, and we're learning a lot, and it's doing some really impressive work. Just want to remind you, this is also a spacecraft that was built by Lockheed Martin. And a lot of these spacecraft you'll see are built by Lockheed Martin, all local. We were very fortunate to go. The funny thing about the Juno thing, I went on before it was launched, they allowed us to go in there, and I met the engineer. They had to put all the wiring inside that thing. Unbelievable, because the radiation output from Jupiter is so high that they have a lead box that they have in the back of the spacecraft to shove all that stuff in there. So, his whole job is nothing but trying to plumb a spacecraft. It's pretty cool, and but it's going very well now. This is the kind of imagery that it's taking of Jupiter. The big story for pretty much last year was a spacecraft that's been on orbit around Saturn's system for 13 years. And after that time, they plunged it into the planet. Mainly because they didn't want to have this spacecraft run into one of the other moons of Saturn that might have life. So they plunged this thing in, and what did I write here? I'm just trying to remember everything. This all happened September 15th, 2017. It was the last gasp of this spacecraft, but an incredible imagery. I tried to talk a little bit about the International Space Station. How many people have seen the space station fly overhead? It's pretty impressive. It's been there a long time. And Peggy Whitson, what did I write about her? She won the spotlight for records, including the oldest woman in space at 57. She has the most cumulative time in space, 665 days after a bunch of flights to the station, and she's the most experienced female spacewalker with 53 hours and 22 minutes, but she was a great asset to the International Space Station. If you've ever heard her talk about life in space, she's a great communicator and really pushed the space station story forward, and a great astronaut that we've got in our Corps. One big thing to watch, and this is something that's coming, I don't know how many people here have voted for Trump and Pence and the whole crowd, but there is a new thing going on in space that I think most of us that write about space are very glued to, is the National Space Council. They reactivated this thing. It's been moribund for a number of years, and what they're trying to do is put together a new space policy for America. Where are we going to go? Where is the next decade or so? And it's back to the moon. I mean, one of the big precepts of the Pence is the vice president running the National Space Council. It's really getting back to the moon. We haven't been back to the moon since December of 1972. Apollo 17 was the last human mission to the moon. But we're going back. And it's really intriguing right now of what's going to happen in the next few years about getting back to the moon. And with humans and a lot of robots. Obviously one of the big stories, and he'll show up here later, is Elon Musk. I know many of you drove the Tesla car here, but Elon Musk runs Tesla, but he also runs SpaceX, a rocket company that has proven that you can reuse rockets. He's done an incredible job at SpaceX, and they have a huge launch list in 2017, and they're going to have some new, really exciting missions coming up here shortly. But the cool thing about this is that, you know, the first stage of the vehicle flies back down to a platform, either in the ocean or on the ground, and he has reused the vehicle, the first stage, over and over again now, and he's proven that. So we're in some really unique period of reusability of rockets. And if you're an economist, you go, well, reusability is probably pretty cool. It's not like every time we fly across the coast and we crash the plane and we never use it again. So Elon has proven to be a very meaningful resource in the future of space exploration. He's got big plans. His story is still to unfold, anyway.
Hey, Leonard,
Yeah.
what happened with that DOD payload that
Yeah,
he said, she said, are they
Yeah.
gonna be okay after this?
Well, that's on the classified slide. They won't
You have to
come
kill
up.
me if you show it.
Well, he launched a payload for an unknown government agency. Northrop Grumman built the Zuma, it's called Zuma payload. The Falcon 9 launched the thing, and we don't know what happened. Either the satellite went into the ocean, some people say it did, some people think it's in orbit. Anyway, I just listened to them testify in front of Congress 2 days ago, and he goes, not Elon, but his launch vehicle guy, our booster worked great. We didn't have any problem, and that's all I can say. So you're left with this mystery satellite that either went into the dump, and nobody knows what it's supposed to do. Northrop Grumman's being held accountable because they built this launch ring, some kind of fitting on top of the Falcon 9 that was supposed to eject the thing, this secret satellite. Of course, they're not saying anything. The Defense Department had a press conference where they said nothing. So nobody knows where the satellite is.
So it's
And
not
this-
bad news for SpaceX, you're saying?
Huh?
It's not bad news for SpaceX?
They're moving ahead with their whole launch
Because they're trying to
vehicle.
get man-rated to go to the space
They're
station.
doing all kinds of stuff. They say, hey, not our problem. We can't tell you why, but talk to the Air Force. The Air Force says talk to SpaceX. So you're in this limbo.
From the thing that I was reading about, though, the rocket performed beautifully.
Yeah.
It was just when they don't know if it clearly did, the payload did not separate from the upper stage
Okay.
because of Northrop
Maybe
Grumman's
that's
ring,
the
which happens a lot, right?
It can happen. But, you know, nobody knows what agency it belonged, the satellite belongs to, what it was supposed to do, and also the cost. I mean, you know, my guess it's probably over $1 billion has went somewhere. So your money is at work, as always, like the
Come on,
government
it's
shutdown.
rockets.
So anyway, one other thing that happened this last 2017, the asteroid planetary defense concept of, you know, if an asteroid's coming with Earth's name on it, and we got crosshairs on Earth from an asteroid coming from afar, what do we do about it? There's really a pretty good program now of integrating various agencies in the government, FEMA, and Homeland Security, and NASA, and Defense Department, to try to create some kind of warning system, and if we got an incoming asteroid, what do we do about it? So that was a bit, it kind of went off the radar screen for a lot of people, but I think that was another big plus up for NASA trying to lead the community, and the White House actually got behind this thing, so it's still evolving. And actually, one of the cool stories was they've actually used a flyby of an asteroid to do a test program of how they would coordinate. So they've had some flybys of asteroids that come in very close to the Earth and used that as a test bed to try to make sure that we know what we're doing. If we're coordinated, are we coordinated? What agency takes the lead? What kind of observations are needed? How would the DoD be activated to do something like launch something, blow it up, or try to move it somewhere? Anyway, I think it was one of those stories that kind of came and went, and I found it pretty interesting. I follow a lot of China because I think there's the story. I think that's the big story to me, and I've been keeping an eye on all the China space activities. However, they had a big booster failure. And this is the Long March 5, which is a pretty heavy lift vehicle that needs to be operational to launch their lunar spacecraft that they've already plotted out. This Long March 5 is the class of vehicle they need to launch what they call the Chang'e 5, which was going to land on the moon, pick up samples, rocket them back to Earth. It's pretty bold because it hasn't been done since the 70s, late 70s. So China is on the hook now to try to get this launch vehicle. They had a failure launching a telecommunications satellite, a giant spacecraft, and it failed. And they're perhaps going to launch another one at the end of the year. So we'll have to watch and see how China does. But it's integral to this return sample program. China, if you don't know, has already landed on the moon and done some pretty impressive lander and let a little robot out and then kind of surveyed the moon. But they want to replicate all that, and they've got a pretty active moon lunar program. In fact, I'd watch the moon. The 2018 is going to be the year of the moon because there's a lot going on, and one of them, well, let me back up here. I'll forget that. Okay. They also had some very good, successful things. They have a refueling capability in orbit, which is a major step forward for their space program. And they can refuel in orbit their space station that they plan to have in Earth orbit in the mid-2020s. So this is a key element. They proved that they could do that, and they've refueled numbers of times with this unpiloted vehicle. So that was an important step. This is another one of those military things in space. We don't know what it's doing. Last year it flew, this particular vehicle flew for like 600 days in Earth orbit. It's a little mini space shuttle. And I keep an eye on this, and as much as I try to clear my glasses, I still don't know what this thing does. But whatever it is, when you talk to generals, they go, "It's a wonderful program. Next." So they don't tell you much what's going on here. It's a mini space shuttle, has a little payload bay. It flies just like a drone. It flies back and lands on an autopilot back to, used to fly into Vandenberg in California, now it's flying into Florida. And it's pretty cool. And there's another one up there right now as we speak. And my guess is it's going to try to break the last record of 600 days in orbit. So nobody knows what that's doing. The Chinese are very wondering what it's doing, as well as the Russians, but nobody's talking. So it's pretty cool. 2017 was rife with Mars curiosity. This thing landed in August of 2012. This is sort of a recent picture it just took. It's up on a thing called Vera Rubin Ridge on Mars, and it's overlooking a lot of things. It's taken some really good observations of habitability of Mars. Is Mars a place where life could have, should have, never did, it's dead, it could be there? Life. So it's pretty cool. But how many miles? Okay, there's the contest. Okay, it landed in August 2012. And here we are today. And It's just ready to make a new milestone in the odometer since it landed. How many miles do you think the thing has gone? 50? Okay, I mean, it's the first bid. What do we got?
7.
7? 7 miles.
The odometer's turned over twice.
Yeah.
But it started
Okay.
at 10, so.
Okay. It's gonna hit 12 miles.
12.
Okay, now any of my astronaut friends go, I can beat that. And, yeah. So, but it's not fair because it does stop and start. It has robotic arms. It's really analyzing the area. But some pretty cool things coming out of Curiosity. In fact, in the last few weeks, they ran over some stuff, literally. They actually drove back to look at it because they saw some feature that they've never seen before. And some people jump right away to fossil evidence of life in the past on Mars, and it's still playing out as we speak. Doubtful, but it's still an amazing piece of machinery. It's a 1-ton robot.
What did they see?
They saw
Bones
little
sticking out?
tubular wire things on top of a rock surface, and to be honest with you, I fell into it because I saw those. I go onto these pictures pretty much every morning, and when I saw it, I go, I've never seen that, and I've been looking at those pictures since 2012. And sure enough, when they looked at those, they drove off, and they go, wait a minute, we better go back. And so they actually do more, and I guess we're going to hear probably soon what their really analysis is. And it's doubtful it's fossil evidence, but it's definitely a different kind of feature, and they don't understand exactly what they saw. So but that's exploration. That's why we do this stuff. It's kind of fun. The biggest story was clearly the August eclipse. We went to Casper, Wyoming, and had a great time watching with a lot of other people the big eclipse. How many people here were tuned in on that eclipse? Yeah, pretty cool. I will say it's to me, the whole thing was like a shuttle launch. It just it just happened so fast, and you're going, can we roll that back? So anyway, it was pretty cool. And next thing to watch, January of 31st of this year, we celebrate the 60th anniversary of Explorer 1, the first American satellite ever launched. And it burned up, a long time ago. But this is a picture from the National Academy of Science. You got Pickering, who ran Jet Propulsion Lab. You got a guy named Van Allen. You know the Van Allen belts? You got Wernher von Braun. And these three were pretty much the leaders of a first American attempt that was successful, Explorer 1. And that was a long time ago. But this is there's going to be a big kind of anniversary of the first launch of our American satellite. This is post Sputnik, which is October 4th, 57. This was the kickoff of the space race, and very successful satellite. It detected Van Allen in the middle. That's why we call it the Van Allen radiation belts. He had a Geiger counter on there and said, there's something happening with this radiation around the Earth, and he first detected it. Sputnik didn't do that. It was the beep that everybody heard, but Explorer 1 really provided some first scientific evidence of radiation fields around the Earth. So it's a great tribute to these guys. Watch for India in the next few months. They're going to launch the moon. India has their own space program. They have their own booster capability, but they're going to launch this triple landing on the moon, and I hope all success for them. It's just that they work very hard on these missions, and this will be a first lunar lander attempt for them. So that's in the next few months. So keep an eye on that.
Where's it gonna go?
To the moon.
No, where? I mean,
I don't think I've ever heard exactly where it's
It's gonna be
landing.
high latitude because of the
Yeah.
solar panel.
Yeah. So I'm not sure. I don't think they've actually announced where they're landing. I think they're just worried about getting,
Success is excellent.
huh?
Their success is excellent.
Yeah, they're doing great.
Like Mars.
Oh,
First
India,
try.
India has a
Yeah.
probe around Mars. They have a Mars orbiter. And so India is another country that's coming along very rapidly with a lot of capability. This is the guy to watch early on this month, I think, if everything goes right. Elon Musk, the Tesla man, but he's got SpaceX. He's going to launch for the first time this Falcon Heavy. We have a Falcon 9, so you've got to have a Heavy. But he's got all these strap-ons, 27 engines. This is going to be the biggest launch vehicle that take off. I don't know if it's the biggest, but it's or the most powerful. It's definitely powerful.
So
this
the
is
strap-ons
off.
are liquids too, and not solids?
No, it's liquids, all liquids. All of those first stages are going to land back on the ground. 27 engines, and we'll see. Elon Musk is not sure it's going to work. And he's the first one to tell you, you got to come. It'll be a big event one way or the other.
This is a really cool approach, because this is the way the Russians do
Yeah.
rockets, with
Yeah.
lots of little engines,
Yeah.
and they failed by the early 70s, they maxed out.
Yeah,
And the United States did the Saturn V, we had ideas for bigger rockets that we never followed up on. But, now he's back to being able to
Yeah.
say, okay, now we can control 27 engines at once and make it work.
Yeah.
And that would be super cool.
and again, computer technology and however, nobody knows what's going to happen when it ignites. They're probably going to test fire the engines on the launch pad. And the cool thing that's kind of a historic thing, it's pad 39A. This is where the Apollo 11 left. This is on the same pad that Elon has bought and basically refurbished for his flights. So he doesn't know what it's going to do, but he's counting on this vehicle to be a Mars class vehicle that will launch people to Mars for colonization purposes and to show his gusto. Elon is launching his Tesla car on top of this thing. This is real. He's got his own car. He's put it into the nose fairing, and so he's launching his own Tesla. So we'll see. I
Is it
don't know
gonna
what
beep?
will
I mean,
happen.
is it gonna send anything back?
Huh?
Is
Yeah.
it just beep so we know where it is?
Yeah, no, he said he's gonna turn on the radio and have David Bowie playing. I don't know what's gonna happen.
Then it's going to Mars, right? Mars orbit.
Why not? Yeah.
It's
I
like,
mean,
we can't
he's-
get an
we'll
orbit
see.
and stop, right?
Maybe, we'll
But it
see
can
what
fly by
happens.
Mars.
It's a test thing. He's paying his own dime on this stuff, but he's a great entrepreneur and a cross advertising guy. Keep an eye on this. This is a Chinese space lab that was launched many years ago. Depending on who's talking, and the Chinese are not talking much, it's probably out of control. They don't have any control over this thing. It weighs something like 19 tons. It's going to come in March, and there's a lot of worry about this particular spacecraft because it has a lot of fuel on board. Chinese say, don't worry, the Earth is covered by a lot of water, but there's a lot of people concerned about big objects coming in like this. So this is pretty much in the March timeframe that this vehicle, it's unpiloted, there's nobody on it or anything, but it's sort of dilapidated early space lab Chinese spacecraft that's very big, and we'll see where it comes in and how much. Some prognosis suggests that some parts of this vehicle can make it down to the Earth. Okay, the Earth is also covered by a lot of water, so you don't know.
Do you remember John Belushi doing Skylab?
Yeah,
Right.
yeah, it's the same thing. I love it. I love all this stuff. But I don't think we want people to be worried about these things. But we have to. These objects are getting very big and complicated. And one of the big stories that's going to happen in 2024, 25, what do you do with the space station? How do we deorbit the space station? Huge facility. And should we? And should we break it apart somehow and use it somewhere else? I don't know, but these reentry of these large spacecraft is worrisome. for a bunch of things I'm not gonna talk about, but I think we ought to be keeping an eye on this one. It's gonna
Well, they
be,
brought down Mir,
yeah, we brought down Mir.
and actually
The
predictably
Soviets.
enough, people flew to Fiji to watch it.
Yeah,
Just like Eclipse.
yeah,
Yeah,
exactly.
Yeah.
China is keeping an eye on this, if everything goes right, even though the return sample moon program of Shang 5 is not gonna go for another quite a bit of time. But Chang'e 4 is really actually being prepped for launch this year. And it's a far side lander and has a rover and won't return samples, but it's a different launch vehicle. It's not the Long March 5. It'll launch on another vehicle that's more successful. One thing to watch is, that blue line going up. They're going to launch a relay satellite first and put it into an orbit around the moon so that actually they can communicate with the spacecraft on the far side of the moon. So, and this turns out to be one of the key things that every nation is going to need if the moon program really evolves robotically in the next year. We need relay from various parts of the moon to this relay satellite back to Earth. So, there's rumors that the Chinese may sell Datacom on that thing. I'm not sure if that's true yet, but that's classic. Communist country telling us how to make profit on the moon relay. Okay. It's
Linda,
2018.
are we in competition since with Pence's is this like a race to the moon, or who are we competing with?
Well, you could look at it as a competition because I think initially, if India goes first, the next few months, they show a culture and attitude about going back to the moon, and they get a lot of diplomatic, kudos, for pulling it off. NASA is trying to assemble a lunar program right now, and Russia's got a program with the European Space Agency that will land robots on the moon. And then you have, like I said, the Chinese. So I don't know. I don't think it's a space race because at the end it may become a cooperative. I hope. There's so much talent in these various countries. It'd be nice to coordinate these landers. And the problem the U.S. has had is that we're bound not to work with China. And there's overtures now coming out of the Trump administration. Perhaps we can find some ways to work with China. We certainly can work with Russia because we do that already with the space station. So I don't know. It's a good question. There's science. Never mind the diplomacy part. There really is a lot of good science to be done on the moon. I'm right in the middle of a book on the moon, and when you look at what we don't know about the moon, even though it's right there, and you go talk to 4 different people about where wait a minute, the origin of the moon, where is it? Where did it come from? And they go, we don't know. We don't know. We spent $25 billion sending 12 people there.
Sure we do, Leonard, come on.
No,
The moon was formed by a giant impact of the Earth.
okay, there's one
That is
view.
the main result of the post-Apollo world.
Okay.
We know that.
I know, I'm gonna put you up here with Jack Schmidt, who walked on the moon, and you can
And
argue
Jack,
all
that's
day.
always Jack Schmidt's angles. I walked on the moon, therefore I know more about the moon than anybody else.
Okay, well, maybe so.
And I like Jack Schmidt.
And he's a geologist, like you
Yes,
are.
but come on. There's a lot with the moon. The moon's an exciting place, but you can't say we don't know where the moon came from. We know
Okay,
it.
Well,
I'm just saying, some people say they don't.
And I just have to say, our next speaker is Bob Grimm.
Well,
He'll clear it all up.
Speaking tonight too.
No, it's all, no,
No,
but
but
your points are all good, but the thing I would add is that the United States does not have anything on the books right now to
Yeah.
go back to the moon.
Yeah,
Whereas China does,
India.
Russia does,
Russia.
and India does.
Europe.
And they're all doing it because these are new, well, except for Russia, who's landed on the moon before with robots. These are new spacefaring nations, China and India. So they're proving what they can do by having a moon program.
Okay.
And they're gonna do great at it. And we don't. So the vice president said yes, we're gonna go back to the moon. everybody wants to go to Mars, but it's too expensive and too far away. So under the Bush administration, we're gonna go back to the moon. Obama administration said we're gonna go to Mars. Now Trump administration says we're gonna go back to the moon. That's all good as long as we do something.
Yeah. And somewhere in that process, we'll iron down this origin of the moon. Some people they criticize different people for, their beliefs, but I don't know. We'll see. I think it's fun.
Moon came from a giant impact from
Okay.
Earth, okay?
Your bet's on the table.
I think it came from a hole.
So
in
you
the
have to
North
believe
Pole.
in scientific consensus.
Okay.
Let's also remember there's people that are swearing that the earth is flat right now.
Thank
That's
you.
right.
There's a genuine website of people that believe.
Okay, I'm just a journalist, I know. Okay, this is the relay satellite that China put in the Earth-Moon system. The big new thing, and we may see something happen this year, is the private sector. The Google Lunar X Prize is open for multi-millions of dollars to land a payload, a private moon craft. And this is Moon Express, their logo, but there's a lot of other private companies now in India, Japan, and the United States that want to put a little lunar rover on the moon and run it. And it depends on, what it does, and you can win some Google Lunar X Prize money. But something's coming, and I think keep an eye. Carnegie Mellon, I think, is one of the best of the crop. But we may see a private sector moon landing, and then we get into this legal battle. Who has the right to land on the moon, and can you claim anything? If you're looking for ice, or can you provide services to NASA or other countries? I don't know what's gonna happen, but the legal people are already alive and well on the moon, with no oxygen to spare. Okay. The big story for me, I've been following this for quite a while, is InSight. Again, Lockheed Martin, this is their InSight lander. It's going to launch in May 5th of this year from Vandenberg Air Force Base,
Cinco de Mayo.
California.
Yeah.
And we're going to go see this thing Tuesday, and it's going to have all the solar arrays out
At
and everything, and
Lockheed
they're going to
Martin.
wrap it up and move it over to there.
Down at Lockheed Martin.
Lockheed Martin.
And then they're gonna serve it.
So it's a very exciting, it's a seismometer experiment, it's kind of a geophysics experiment. But this is the kind of a French-built seismometer that we think is working great now. They delayed this launch from 2016 to 2018 because of this problem with this seismometer, because that's the key thing. You're gonna put the robot arm, drop the seismometer, listen for Mars quakes and what's going on with Mars. Interesting, it's based on a Lockheed Martin concept for a Phoenix lander, and has all the trappings of being successful, we hope. So that's going to take place in May of this year. Keep an eye on Richard Branson and his Virgin Galactic group. This is a suborbital private sector possibility of taking passengers up. I think we're there at $250,000. We can't afford this.
Yeah.
A seat, you get to keep the helmet. Straight down. But you get, there's 6 people and 2 pilots that'll take you up to suborbital height. Not into Earth orbit, but this goes, like 60 some miles above the Earth. Great views, wonderful experience. They had a failure several years ago, and they killed one of the pilots in the test program, and it's taken them a long time to get back into gear. They just had this flight, the 7th glide flight, drop from that plane at 100,000 feet or so, and this was the 7th glide flight. And the rumors are, and I don't know if it's official, but I think the next flight will be kicking off the engine for the first time, and actually taking the pilots up to pretty high altitude and testing out the hardware. Their hope is by year's end, perhaps early next, to start taking paid passengers up to suborbital flight. This is Virgin Galactic. This is Richard Branson. a lot of hype, a lot of interesting technology, but it shows a trend in the whole private sector capability now to offer commercial services to space people. Next thing is, there we go. Here's another competitor. How many here are Amazon Prime people? Okay. Your money is going into this kind of thing. This is Jeff Bezos. He's running Amazon.com. He's the richest man on the planet as of last week or week ago. So he's got a lot of money. Nice guy. Seems like a nice guy. He's built a new Shepard vehicle, and on the top is a capsule that, again, will take a crew of passengers up to suborbital height, and you parachute back down. His first stage is like Elon Musk, lands back on Earth. And here's a picture of that coming down after it's deployed the capsule. So, and it's been reused, and so, again, reusability of rocketry is coming into vogue, and that's a big, big story in the whole history of the space program. He actually launched a dummy on this last flight a month or so ago, and I can't remember, this was like Luke Skywalker, what do they call him? I don't know. It was a dummy in there, a mannequin. But they pushed him up, they flew the capsule. The biggest promo these guys have got, we have the largest windows. I mean, this is where it's gone now. It's like commercial space. So, we'll give you this seat harness and everything, but we have the largest windows. So if you get up to 62 miles up in the sea, you're gonna have a great view. So they flew this mannequin up to altitude. Here's the mannequin at the epic part of the flight, and they landed it back down on the ground. So anyway, large
There's no
windows.
toilet.
No pilot.
No
This is
toilet.
all.
Toilet.
It's very fast, right?
What was it?
No
Compared to
toilet.
No toilets.
Yeah.
Well, it's pretty fast. I don't know, maybe don't. We don't wanna talk about that.
Fishy fly.
That's extra.
Well, but
It
there's
costs you
no
extra.
getting up, there's no, I mean, with the Richard Branson one, you have to do this long airplane flight.
Yeah.
And then you get your little ride.
Yeah.
And then you glide down. This is straight up and straight down, right?
Yeah.
So
Landing.
go to the bathroom before you leave.
I told
That's why they need the big windows. They don't want any of this bad press. Okay, we have the Parker Solar Probe. That's gonna go fly this year, and I had to write down when it's gonna go. Summer of 2018. This thing flies how close to the sun? What's
12
the-
million miles.
How many?
12 million.
12 million miles. So this is it's gonna be claimed to be the closest object we've ever,
By far.
by far.
Yeah.
And it won't melt.
That's what that big black thing in the front's for.
So the camera is way, way back. They're shooting
Yeah.
through a little hole. It must be like, a meter or so from the front of that to the telescope that's way, way
Yeah.
deep on the other side.
Yeah, this is still Applied Physics Lab in Laurel, Maryland, built this thing. It's an amazing piece of hardware. So anyway, keep an eye on Hayabusa 2. This is Japanese asteroid mission. Arrives in early June 2018 to explore an asteroid, and actually it does a lot of stuff. It's going to drop robots on the top of this asteroid and collect samples, get those samples back eventually to Earth. But also at the same time, we've got American NASA spacecraft, OSIRIS-REx. Its target, I wrote down, was August of 2018. It'll be arriving at an asteroid. So we got a lot of asteroid news this year. And it, again, will collect samples, put them in a little canister, then eventually have this canister come back to Earth with the material. So pretty cool with asteroids this year. Pepe Colombo, this is a European Space Agency mission. This is a dual mission, 2 spacecraft mission. And maybe Bob, you know more about Pepe Colombo than I do. What's the point of this versus like Messenger? What would be the difference between, because we've had NASA have the Messenger spacecraft. Is this just a repeat of Or totally
It's-
different?
It's Europe, so they're doing their own thing. I mean,
Yeah.
they do what they wanna do. But the two spacecraft is so they can measure the soul of the whole sort of particle and field environment than the messenger could. So it's more space physics and less geology.
And for a planet that's so close to the sun, we're still puzzled over ice on the poles.
I don't think it's so much looking at ice in the poles.
Not this
I don't
year.
think I mean, ice in the poles of Mercury is very easy to understand because Mercury basically is straight up and down. You know, it doesn't have seasons like the Earth does.
Okay.
So its spin axis isn't at a big angle, so it's more or less going around flat.
Yeah.
And that means that if something lands on the pole, it's gonna, if it's in a crater, it's gonna be out of the sunlight.
Yeah.
And comets have landed on Mercury and all the ice has gone to the poles and it's happened on the moon to a lesser extent. So it's just remarkable on Mercury that it's so close to the sun.
Yeah.
And there's places that are shadowed that are just completely hidden in
Yeah.
intense sunlight for, a billion years or more.
Yeah.
But yeah, it's a cooperative thing, right? Isn't it between the
Yeah.
Japanese and the Europeans?
Yes, yeah. So I think
And
we're.
there's one US
Huh?
instrument, there's a couple US instruments on it.
Yeah.
And then,
I've done nothing but a disservice to everything else that happened. I couldn't get it in because she said I went 20 minutes. I'll blame her.
now didn't Messenger only recon like 60% because of the orbital resonances? And this is supposed to recon the whole surface?
That'd be great if they could sort of finish it out, yeah.
Yeah.
So know your Mercury. So we got a lot happening in the government sector, multiple nations doing things. I think this is a year where private sector space is really gonna come into vogue more. And we could have a lot of explosions, and Tesla cars flying off the line. I don't know, it'd be a cool year. But it's, again, it's a disservice, there's so many things I didn't cover here, but the trend lines are international space activities are growing, and with very bold missions, and in my view, NASA's still trying to get its act together, literally, Space Act, trying to figure out where it's going to go and how much money we're putting into the space program. We have this new National Space Council that's supposed to be helping define private sector space, government space, where are we headed cooperatively with other countries. So that's going to play out this year, 2018. So it's an exciting time. And, I'm just too old to go through this too many times. But it's relatively, there's some new threads here that are going to be very interesting to watch. And so keep an eye on the sky. Where are we?
There.
Next,
Okay,
somebody else.
yeah. Yeah, this is kind of special for me because usually Leonard does, for those of you who haven't been here before, he does like 5 or 10 minutes kind of update from the last month or so. And then I'm like trying to pull the hook so we can get to our main speaker. So, I'm glad I had a chance to really, talk a lot about, the whole last year and into the future. There are a couple things I wanted to say. One is, that's great, Lucy, thanks. And you need to teach me how to use the lights. Because I'm not sure. But I wanted you all to know, because I know some people have said in the past that there's like a glare from one of these lights, and you can actually move them. Can't we? Okay. And sound-wise, I was in the back, I think everyone could hear Leonard. But we do have a PA system here that we can put our speakers on. We want to make sure everybody can hear. And there are chocolates back there. So if you didn't see those.
Well,
Thank you for everyone who.
There were chocolates back there.
But yeah, and the heat too. George went back and he turned the heat on, and I'm like, great, if we just want to make sure it's comfortable for you, so if you, yeah.
It's the fluorescent light back there that shows on the screen.
Oh, that one, that, okay, we can shut that one off, right? Susie, that's
Which one?
the fluorescent one.
It's in the kitchen.
Not the one in the kitchen, but the
No, the one
one that we
outside
leave on
the
at
kitchen.
night.
It's in, the switch is
Oh,
in the kitchen.
Yeah, okay, yeah, I'll go take care of that. How's that? Is that good?
There is a dark side.
And, do we need
Or is it all dark?
more light for the speaker, or, how are these?
I'm not gonna talk much anyways.
You know, after 4 years, I'm trying to get this right.
Yeah, that's good. Thanks,
Yeah,
John.
is that good? Okay. Just want to say a couple of other things. Let's see. Also, you know, and I can say things later too, so, and I'm looking at what I'm doing to later. But I do want you to know that, our presenters put a lot of time, as you'll see in Sam's, you know, because, well, and John's and Hunter's, they put a lot of time into putting these talks together, and people we have from Denver and Boulder who come up, and Bob Graham, you know, our local people too. So, one thing I wanted to let you know is that usually, you know, we've got a list of about 150 people on our email list, and I'm worried about sending it out to everyone. But if you'd like to join us at the Wonder View, we're kind of getting into this as a regular thing, about 4:30 or 5, before the meeting. So everyone's welcome on their own dime, although we treat the speaker, we don't, Skywatchers treats the speakers. That's where some of the money that we donate goes to. If you want to give a talk, you don't have to be an expert. You can choose a subject, we'll help you with it. If you give a presentation, you're free for life, never have to contribute $5 again. So just want to put that out one more time. So next, we have Sam is going to, this is over how many years have you taken these
Well,
images?
yeah, I guess I got started about a half a lifetime ago. So,
And he's the same age as me, 70, so 35
a
years
couple of
ago.
decades anyway. And go ahead.
Yeah, so, I think you'll really enjoy this, but, we want, like I said, for each of our astrophotographers, and we've got quite a few in our group, some are here tonight and some aren't, but we want to do this every time, have, you know, maybe 10, 15 minutes of them showing the best of their astrophotography. And on a clear night, get you guys out there if you want to bring your cameras, even, we've got a iPhone holder, a smartphone, to take pictures too, through our telescope. So, let me turn to Sam.
Well, I'm Sam Reed, and rumor has it that I've done a little bit of astrophotography over the years, and that may be right, I guess. I actually got started, like we said, a couple of decades ago, and I lived in the northwest corner of New Mexico at the time, and I worked there. And I bought a couple of acres out in the boonies among the piñons and the juniper trees, and I built a little house out there. And there weren't too many houses out there at the time, so it was really dark. And there also wasn't a whole lot to do out there either, so I decided that I might as well take advantage of the dark skies out there and get a telescope. And so I ordered a little Dobsonian from Orion telescopes, and I used it for a while, and then I thought, yeah, it'd be kind of nice if I could take some pictures through this thing and show other people what I was seeing. So I had a little point and shoot camera at the time, and I figured out how to hold that camera up to the eyepiece on the telescope, and I got some pretty decent pictures, I guess, of the moon and the planets and stuff, but the telescope didn't track at all, so you couldn't do much with anything much fainter than the real bright stuff. But over the years, one telescope led to another, and one mount led to another, and one camera led to another, and pretty soon I've got a lot of money sunk in astronomy equipment. And at this point, I think I'm about equipped to maybe start doing some serious astrophotography. It's taken me quite a while to get there, though. And along the way, I've
launched quite a bit of colorful language into the sky. So, Barb asked me to put together some of my astrophotography, and it's kind of probably spread out over the last 15, 20 years. Some is better than others. The slideshow is going to run by itself, so I'm not going to be talking during the slideshow.
Well, but he did the music that goes with it.
I had a...
And that, you said, took longer than
Well,
putting the slideshow.
I had a string quartet lined up to do
Yeah,
the
right.
score, but they backed down at the last minute, so I had to improvise. So here's the thing. I know there's probably a lot of people in here who appreciate music or are talented in music. My sincere apologies. I probably hit some sour notes.
Will you at least like say, like, this is when I changed to like this major advance and like, sort of just general things about how you progressed? Are we
You
gonna
mean
see?
as far as equipment goes?
I mean, are we seeing your pictures with time, or are they just,
Well,
or whatever?
No, I didn't order them
Okay.
by time, but you'll probably see that some are a little bit better than others.
Okay.
Oh, I do have one other statement to make, which is one of these pictures I did not take. And you may have to guess which one it is.
Toward the end.
Toward the end. The end.
There's a prize, right?
Pardon me?
There's a prize, right?
A prize? Oh, for identifying the picture.
Yeah.
You get a chocolate.
What else?
Where in
Oh.
Mexico did you live and observe?
It was like northeast of Farmington. And it was probably one of the few places in northwest New Mexico that had trees.
Yeah.
So I really lucked out when I got that property. It was a pretty place. So, anyway, I'm gonna go ahead and start this and let it run through. And then if you have any questions, most of these objects are deep sky objects, which means that they're outside of our own solar system. Not all two that are closer by, but a lot of them are within the Milky Way galaxy. There's some clusters and hydrogen gas clouds, things like that are relatively nearby, maybe 100 to several thousand light years away. Then we go to some objects that are outside the Milky Way. The Andromeda Galaxy is one of the closer galaxies to ours. It's 2.5 million light years away. There's some of the Virgo cluster, center of the Virgo cluster, which is 2,000 galaxies. Center of the Virgo cluster is about 54 million light years away. And then some, namely Stephan's quintet, which I have a picture of here, is several hundred million light years away. So when you're looking at these pictures, you're looking back in time progressively the further out we go. So kind of hard to wrap your mind around that kind of distance. You know the photons have been traveling for 300 or 400 million years. So hopefully this is going to run okay. We tried it out the other day, and give it a shot, see how it goes. It should.
Okay. You gotta hear that. You worked hard.
Sorry, I went over the edge on this one. Anyway, I guess we can have more lights on. I probably had a lot more fun making that than you guys did watching it.
Yeah,
Like I
and such
said,
a,
I went off
almost
the
like a
deep end.
meditation, you know? It was like a little break and then moving. But yeah, that was
So-
great. And the dog there is Dewey, and that was great. You said, I said, well, how come we were both looking up at the same time? What, you saw an airplane flying over?
Yeah.
And something, and Dewey looked up too.
All I have to do is say, "What's up, Dewey?" and he goes,
Oh, that's awesome.
Yeah, yeah, that was great. Thanks.
any questions or anything?
So the Longs Peak one. So you were up there at night?
No, that was, Long's Peak was
Okay.
in the background
Okay,
there.
okay.
I'm sorry, maybe it wasn't
All right.
that obvious, but Want to see the colors?
How true are
How
the
true
colors
is
in the
When you're
photo?
out.
Most of them, it's true color, because
Nice.
when you're doing those, you take a monochrome shot, or several, or a lot of them,
And then you overlay.
and then you take more frames through a red, a green, and a blue filter.
Gotcha.
And so it's an RGB kind
Right.
of a combination. So the end result is pretty much true color.
Nice.
Now, you're not gonna see this kind of color through a telescope. You're gonna see, when you look at a galaxy through a telescope of any reasonable size, you're gonna see a faint fuzzy, what they call a faint fuzzy, it's just a blob. Your eyes are just not good enough to pick the color. What was that Moody Blues album? They said, cold-hearted orb that rules the night, removes the colors from our sight.
Red is gray and
Yellow
yellow.
light. We decide which is right and which is an illusion. But some of them, a couple in there are made with narrowband filters, which means that they only pick up hydrogen alpha, which is a very, very specific wavelength of light, sulfur ions, and oxygen ions. And that kind of a picture, you can almost choose which channel you want to assign. The Hubble Space Telescope assigns hydrogen as a green channel, and that's why you see a lot of its pictures have a green, blue tinge to them. In fact, hydrogen alpha is really deep red if you took a true color
Gotcha.
photograph. So.
I was just curious, were the majority of those shot right here in the canyon? Not in the Farmington ultra dark, west?
I tell you, 90% of them are shot here in the canyon. You can avoid the clouds and the wind.
And then how long were you out there, or how long was the exposure on your tracking telescope?
Typically, you've got to take a number of exposures for pictures like these. And I've gone up to 30 minutes per frame. And you've got to have a pretty accurate tracking mount in order to do that. With today's technology, it's not really that hard. It's still hard. I
It's
still
still-
launch a lot of colorful language.
But it's it's not that hard, but it's, maybe,
That's fun.
yeah.
Anything else?
Sam, what's the longest exposure using your DSLR?
I think I've gone up to 20 minutes with the DSLR. The problem is, as close as we are to a big city here, even though it seems like we see a lot of stars, there's still a lot of sky glow
Yeah.
up there. And if you try to expose too long, the sky glow starts to overwhelm the detail of the picture. So you're better off taking shorter exposures, and that's, even with DSLR, you still stack, 5-minute exposures. You stack a bunch of those together. It turns out that you get better. And then there's always an airplane that flies across, or a satellite or
Yeah.
whatever crosses over. So, yeah.
The gamma ray burster.
You'll actually see on each individual frame, you'll see occasionally where a cosmic ray will come in and hit the sensor,
Oh, wow.
and it'll make like a little worm-shaped
All right. Oh, well, that
mark
was-
on the picture. Little cosmic rays coming.
Thank you.
Very neat.
So before we have John start, I wanted to segue into one of our other astrophotographers who also does some really amazing cards, and I've probably bought 20 of them or so from Dave Trammell. And the moon setting over Indian Peaks. He's got these back here if you're interested. What, $5 a piece? And the epic sunset that a lot of us saw, and some of it, I know Joelle took a picture of it, and yeah, a bunch of us did. And then a really nice one of the moon, and then one of the eclipse too. So those are back just to the right of the kitchen there. Yeah, the wine. The wine. And then after John's presentation, we'll do a group picture. You know, if you're all here, please come up. We'll try to do that kind of fast. I don't think we're gonna have telescopes outside tonight because I think we're gonna have snow or fog.
Use an
But-
infrared scope.
Yeah, hey, whoa, okay. Yeah, right there.
Works on Titan.
Yeah, okay. Yeah, right. So, you know, John is a NASA Solar System Ambassador, and a lot of you know him. He's been here for years with our group and gets the technology working every time. In 4 years, we've had to deal with it a bit, but, you know, we've never had somebody come and go, I can tell you what it showed you. And he also works at the National Solar Observatory in Boulder. And so if you have any questions about the sun, he's the guy. To ask. You know, well, you know, you've only been there a year, right? So-
also not,
Well, okay.
although I did think it was cool,
Website.
we had the AAS, the American Astronomical Society meeting was up in Washington DC. And I got sent up there to be the booth person, you know.
Oh,
I got to meet an astronaut, that was kind of cool. But my boss put on, she goes, "You're a solar scientist," and she puts this thing on. And so everybody's like, "So, tell me something about the sun." I'm like, "Okay." So I was wrong about the Parker Solar Probe. I said 12 million miles. It's, I don't know where 12 came from. It's going to be 4 million miles. 8 solar radius. So
You just looked that up.
I actually did because I was like, I hope I'm not wrong. And we have lovely internet, which today was the closest day I've ever come to messing up. My presentation didn't save right, and so I had to log. I started up the road and I was like, oh, I can just log into my computer now. Isn't technology wonderful? So Barb asked me to talk about, if you were here last month, we talked about the cool astronomy things that like Leonard's talk on space science, the astronomy science that's going on. That was just for December, and it was like, I had like 9, 10 things, but I wanted to really focus on a few things, so I picked the 5 things that I thought was the most important astronomical, not discoveries, but things that went on in 2017. Some of them do overlap with Leonard's, and you'll see that in a second. Well, 2 things do, because the coolest thing that in 2017, obviously, for me anyway, mainly because I work at the National Solar Observatory, was the eclipse. And so this is our setup. We were up in Salem, Oregon, right at Willamette University, which is right next to the Capitol building. And easily there was 2,000 people jammed in this park. And my little station here at the telescope, I made this sun funnel. And so the eclipse is just beginning in this picture, but it was I was very popular, and you know that's just showing some of the stuff. One of the cool things that we did was a lot of outreach. I work in the education and public outreach spot, and if you look really close, you can see somebody put a piece of cardboard and put a bunch of dots in patterns like a star, 2017, and you can, if you look close, you can see the crescents. And we thought that was kind of cool. Now, I didn't get to show my pictures at the thing we had, and so Barb thought it would be cool if I showed some of these. This poor guy, this dog, had had a seizure the night before, and the people just kind of parked him right next to me. But somebody came over with a colander, and of course now you can see the little crescent moons on it. So he slept the whole dang time, missed the whole eclipse.
Did he live?
I think so. He was alive when I'm showing it. So the place is packed, right? The eclipse, what was fascinating was people well, the setup I had is actually like projection TV. Those are sunspots. I don't know if you got a really close look at the sun during the eclipse, but the sunspots were pretty cool. We had a lot of fun with, we trained a bunch of people up, a bunch of high school kids. They're in Salem. CNN did a story, so I put eclipse glasses on them all and took this picture. We had a lot of fun with them. They did a story, and these were all underserved Hispanic kids, and they did an amazing job helping us with the public. We had about 12 stations at our place where we had things like, where we did that little punch thing. We did, we had some UV beads. We make bracelets with UV beads, and so they're white, and then you put them in the sun and they turn colors. And we were interested to see if maybe they would go white again during the eclipse, because there was some confusion about whether the corona actually emits UV radiation. That was kind of inconclusive experiment, but it was still fun to do. The eclipse goes even more, and at this point I gave up looking at I had a big solar filter and took my cameras, and then I took my eclipse glasses off, and I did what you shouldn't do. I wanted to see that transition to that. Obviously I wasn't paying attention to focus. I was more interested in what was going on. But what was cool is that you can see the prominences on the edge, up there and over here, and increase the exposure so I could get more of the corona. I wish I had focused better, but in the end, I got that. I'm pretty pleased. There's a little camera jiggle in it, but so. The next part that kind of overlaps with lunar stuff is the Cassini, the plunge in the atmosphere. This is an artistic rendition of that. And I think it was one of the eclipse was a big event in 2017, but I think after Cassini's 12-year run, it showed us a lot. You know, a lot of people ask why we do this kind of science. I'm sure that Bob gets asked this all the time. And for Cassini, you know, it helped us understand the kind of worlds where life might exist. Titan, which we don't think, you know, certainly carbon-based life might not exist there, but who knows? It had liquid methane ocean, just like Earth. And then we have Enceladus that has water, liquid water inside it. Cassini showed us that Titan is one of the most Earth-like worlds we've ever seen, even that we've ever encountered, even more so than Mars, say, because of the